Today I want to talk about the most important greenhouse gas that you've never heard of. Actually, though, we're not off to a great start because I've already made two mistakes. Firstly, it's not just me who's going to be talking about this. I'm being helped by the one and only Dr. Simon Clark.
Hello!
Check out his YouTube channel if you haven't already. But secondly, you definitely have heard of this greenhouse gas, just maybe not as a greenhouse gas.
Spoiler alert, it's water.
And speaking of spoilers, even though this video is all about water and how important it is to understanding climate change, none of this changes the key climate change takeaway, namely that it's being caused by humans emitting greenhouse gases, most importantly carbon dioxide and methane. And speaking of carbon dioxide and methane, I made a couple of videos all about these gases and how they cause the greenhouse effect on the molecular level. They absorb particular frequencies and then they start to wiggle. And all that wiggling leads to this.
This is what's called the Earth's top of atmosphere outgoing radiation, which is the radiation that the Earth is spewing out into space, what wavelengths of light it is emitting. Now, if you know a little bit about physics, you might expect this to be a black body radiation spectrum, which is the light given out by any object at a given temperature. And that's nearly right. There are basically just a few deviations from that black body spectrum, which of course are those wavelengths of light that have been absorbed by certain chemicals. So there's a little divot here from carbon dioxide, a little cut taken out here by methane. But there are these enormous rents, these great big holes in the spectrum. What on earth could have absorbed those wavelengths, I wonder?
Yeah, you guessed it. These huge missing chunks are down to water vapor. There is just so much water vapor in the atmosphere compared to other greenhouse gases like carbon dioxide. And water vapor absorbs the radiation given off by the Earth in much the same way as CO2 molecules or methane molecules. H2O absorbs the infrared radiation given off by the Earth by starting to bend like this and starting to spin around. All in all, water vapor is responsible for about half the greenhouse effect, which is kind of a lot. Which begs the question, why aren't we talking about it more?
Well, just because water vapor has a significant effect on the Earth's outgoing radiation, that doesn't mean that its effect will change over time. And that's because, well, the Earth's atmosphere can only hold so much water. If you try to add more water to the atmosphere, it simply gets rained out. In fact, the only way to add more water to the atmosphere and keep it there is to increase the temperature of the planet. That's because the warmer a gas is, the more water vapor it can hold before it rains out.
So if something starts heating the planet up, here's looking at you, human emissions of carbon dioxide and methane, well then that increases the concentrations of water vapor in the atmosphere. That increases the greenhouse effect, and that heats things up even more. You can think of Simon as carbon dioxide changes, and you can think of water vapor as his megaphone. If carbon dioxide isn't doing anything, then neither is the water vapor. But if carbon dioxide starts acting up, then the water vapor boosts its effects.
I ain't the sharpest tool in the shed.
The added water vapor amplifies the global warming that we are causing, but it also has other effects. In storms, for example, extra water being present in the atmosphere can be rained out, making extreme rainfall even more extreme. And that's a shift that we're already starting to see happen in front of our eyes.
And speaking of rain, there's another way that water is crucial to understanding the size of global warming. You see, water in the atmosphere doesn't just take the form of water vapor. It also, as any British person will tell you, likes to form clouds.
As a British person, and therefore professional weather complainer, I can tell you that clouds ruin a sunny day. The reason, of course, they do this is because clouds reflect sunlight. They stop light from the sun from reaching the Earth's surface, and that causes the Earth's surface to cool down. Scientists used to believe that this effect would help to counteract man-made global warming, because by increasing the average temperature of the Earth, you increase the average amount of evaporation that takes place over an ocean, which results in more clouds forming. Those additional clouds, it was believed, would then reflect more sunlight away from the Earth, cooling down its surface.
Which would be great, right? Who doesn't like avoiding the consequences of their own actions? And the truth is that exactly what clouds are doing is still a bit of a mystery. They are an infuriatingly challenging combination of hard to simulate and difficult to observe. But the picture so far isn't looking good. It seems like low-lying clouds are getting worse, not better at shielding us from the sun. And that's not all.
Because clouds don't just block radiation that's coming in from the sun. High clouds also reflect outgoing radiation that the Earth's surface has emitted. So it seems that high clouds are actually insulating the Earth's atmosphere. And the evidence so far suggests that, far from undoing climate change, that clouds might actually be exacerbating it.
If you're wondering what all the changes we're talking about here today look like in practice, well then you're in luck. Simon has been hard at work visualizing how water changes in the atmosphere as things hot up.
You can find that over on my channel, up here.
And make sure to subscribe to Simon while you're there for fantastic, delightfully nerdy videos about climate and much, much more. Ultimately, water isn't going to put out the fire of climate change. In fact, to a large extent, water is worsening global warming.
So if we want to stop the world from heating up, and we do want to stop the world from heating up, we can't rely on water to save the day. We've got to stop emitting so many greenhouse gases into the atmosphere, which means we've got to stop burning fossil fuels.
If you're new here, you should probably subscribe. And if you're new to Simon, then you should definitely subscribe to his channel. Oh, and if you have any climate change questions of your own, leave them in the comments below. Okay, until next time. Bye.
Oh, dropped my phone.